In this class, we are going to study about colligative properties. Colligative properties are those properties of solutions which only depend upon the number of moles of solute particles. These properties are independent of the nature of solute and solvent. They only depend upon the number of solute particles, and mainly these properties are affected by the decrease of vapor pressure, the lowering of vapor pressure on addition of a non-volatile solute to a volatile solvent. There are 4 colligative properties which depend upon the number of moles of solute particles. First one, relative lowering of vapor pressure. Relative lowering of vapor pressure. Second one, elevation in boiling point, means increase of boiling point, elevation in boiling point, that is also called ebullioscopy. Third one, depression in freezing point, also known as cryoscopy. And fourth one is osmotic pressure. Fourth one, osmotic pressure. These 4 properties depend only upon the number of moles of solute particles, independent of the nature of solute and solvent. And as we know, when we add a non-volatile solute to a volatile solvent, the vapor pressure decreases, and the decrease of vapor pressure affects elevation of boiling point, means it affects the boiling point as well as freezing point and osmotic pressure. So, all these properties are mainly affected by the lowering of vapor pressure on addition of a non-volatile solute to a volatile solvent. Now, one by one we can study, starting with the first one, relative lowering of vapor pressure on addition of a non-volatile solute to a volatile solvent. Taking the first colligative property, which we had already started with Raoult's law, relative lowering of vapor pressure. For a solution having a non-volatile solute, the vapor pressure of solution is less than the vapor pressure of pure solvent. On addition of non-volatile solute, the vapor pressure decreases because the non-volatile solute particles occupy the surface partially of the volatile liquid, and therefore rate of evaporation decreases and vapor pressure also decreases. So, the vapor pressure of solution will be only because of the vapor pressure of solvent, because the non-volatile solute will not give any vapor, therefore, there will be no vapor pressure of non-volatile solute, only the vapor pressure will be because of solvent, and according to Raoult's law it will be equal to P naught x solvent. Considering solvent as 1 and solute 2, we are assuming that solvent 1 and solute is 2. Then the vapor pressure of solution will be equal to P naught x 1, and it can be given vapor pressure of solution is equal to P naught 1 minus x 2. As we know, x 1 plus x 2 will be 1 for a binary solution. The mole fraction of non-volatile solute and volatile solvent, its sum will be equal to 1 because it is a binary solution. So, total mole fraction will be equal to 1. P solution, vapor pressure of solution can be given as P naught minus P naught x 2. Therefore, P naught minus P naught x 2. We can say P naught x 2 will be equal to P naught upon P naught x 2 will be equal to P naught upon P naught minus P vapor pressure of solution. So, x 2 will be equal to x 2 is equal to P naught minus P upon P naught. It means the relative lowering of vapor pressure, because P naught minus P, it gives the lowering of vapor pressure. It gives the lowering of vapor pressure, and the whole quantity P naught minus P upon P naught, when we take the lowering decrease of vapor pressure with respect to the vapor pressure of the non-volatile liquid, it gives the relative lowering of vapor pressure. That is a colligative property. The relative lowering of vapor pressure is equal to mole fraction of solute. Relative lowering of vapor pressure equal to mole fraction of solute can be used for determination of molecular mass of solute. Molar mass of solute can be determined by this quantity. We know that the mole fraction of solute is equal to number of moles of solute upon total number of moles, that is the mole fraction of solute, number of moles of solute upon total number of moles. For a dilute solution, N2 will be very less than N1, because number of moles of solute will be very less than N1, therefore, N2 can be neglected in comparison to N1. So, it comes P naught minus P upon P naught, P naught minus P upon P naught is equal to N2 upon N1. So, finally, it comes P naught minus P upon P naught is equal to N2 upon N1, number of moles of solute upon number of moles of solvent. P naught minus P upon P naught can be written weight of solute upon molecular mass of solute upon weight of solvent upon molecular mass of solvent. So, to determine M2, if we have to determine M2, M2 will be equal to molecular mass of solute, can be determined by weight of solute into molecular mass of solvent upon weight of solvent into relative lowering of vapor pressure. This formula will directly measure the molar mass of solute. So, first colligative property depending only upon the number of moles of solute particle, not depending upon the nature of solute or solvent. Relative lowering of vapor pressure. Second colligative property, that is elevation in boiling point. When a non-volatile solute is added to a volatile liquid, the boiling point is raised due to decrease in vapor pressure. How it happens? The boiling point increases with decrease of vapor pressure on addition of non-volatile solute to volatile liquid. Second one, elevation in boiling point. Boiling point, we know that boiling point is the temperature at which a liquid changes into its vapor state, it means it boils, and a liquid boils when its vapor pressure becomes equal to atmospheric pressure. Yani a liquid boils when its vapor pressure reaches to atmospheric pressure. So, a non-volatile liquid has a vapor pressure. When it will become equal to atmospheric pressure, it will start boiling, and the temperature will be called its boiling point. Now, on addition, for example, a non-volatile liquid has a vapor pressure P naught. When it becomes equal to atmospheric pressure, when P naught becomes equal to atmospheric pressure, the liquid boils. So, this temperature delta T is called the boiling point of liquid. For example, it is the TB, the boiling point of liquid. Now, on addition of non-volatile solute, the vapor pressure decreases. On addition of non-volatile solute, the vapor pressure decreases. Decrease in vapor pressure due to addition of non-volatile solute. Now, it is vapor pressure of solution. So, we need now to make the liquid boil, we have to give extra temperature. We have to provide extra temperature to make it boil. For example, delta T is the extra temperature to make the liquid boil, to make the vapor pressure of the liquid equal to atmospheric pressure. So, TB was the boiling point of volatile liquid, but on addition of non-volatile solute, now it becomes TB plus delta T. On addition of non-volatile solute, extra temperature is required to increase the rate of evaporation to make the vapor pressure equal to atmospheric pressure. So, it is the boiling point of solution having non-volatile solute. So, when we add a non-volatile solute to a volatile liquid, the vapor pressure decreases, and to make this vapor pressure equal to atmospheric pressure, extra temperature is required. Therefore, boiling point of liquid increases, that is called elevation in boiling point. We can study the elevation boiling point by taking the example of a graph plotting vapor pressure against temperature. Vapor pressure against temperature, if we plot, for example, at this temperature, the vapor pressure of, at this temperature, the vapor pressure becomes equal to atmospheric pressure, means 1 atmosphere. At this vapor P naught is the vapor pressure of pure volatile liquid, and at this temperature TB it becomes equal to atmospheric pressure. Therefore, TB is the boiling point of pure solvent, pure volatile liquid. Now, on adding a small amount of, if we add a small amount of non-volatile solute to this volatile liquid forming a dilute solution, the vapor pressure decreases. So, at this temperature the vapor pressure decreases, and to make it equal to atmospheric pressure, we have to increase the temperature to make the vapor pressure equal to atmospheric pressure. The temperature, for example, it is TB1, it is TB dash or TB1. If we take a concentrated solution, increasing the amount of non-volatile solute to the solution, vapor pressure decreases some more, and therefore, we need some more extra temperature. The temperature should be raised to make the vapor pressure equal to atmospheric pressure. Then the liquid will boil and its boiling point will be taken TB double dash. If we compare these triangles ABC and ADE, considering them like triangles, triangle ABC and triangle ADE. For them, AB upon AD will be equal to AC upon AE, because they are same type of triangle, like triangles. So, their perpendicular, ratio of perpendicular will be equal to the ratio of base edge. AB, it means here the vapor pressure P naught, here the vapor pressure decreases and becomes P naught dash, and it becomes here P naught double dash. So, AB means P naught minus P naught dash, and AD means P naught minus P naught double dash will be equal to TB dash minus